October 12, 1942, the North Atlantic, 800 miles east of Newfoundland. Captain José Ernst Kals stood on the conning tower of U-130, his Zeiss binoculars scanning the grey horizon. The veteran U-boat commander had sunk over 100,000 tons of Allied shipping in his career, but what he saw that morning made him lower his glasses and laugh. A convoy of 42 merchant ships stretched across 10 square miles of ocean, and leading them were vessels so crude, so obviously mass-produced, that they looked like children's toys scaled up to ship size. Boxy hulls with flat sides, identical in every detail, moving at barely 11 knots. Simple, all-welded construction with visible seams, straight stems, no curves, no elegance whatsoever. These were the first Liberty ships Kals had encountered, and his assessment was immediate and contemptuous. He transmitted to U-boat headquarters. The Americans have sent us floating coffins, all-welded construction, no rivets. They will crack apart in the first North Atlantic storm. These ships are an insult to naval architecture. They are not ships. They are emergency barges pretending to be cargo vessels. What Kals couldn't know, what none of the German Naval Command could have imagined, was that he was looking at the weapon that would systematically destroy the U-boat campaign, starve the Third Reich of resources, and deliver the material superiority that would crush Nazi Germany. Within 3 years, these crude emergency barges would be produced at a rate that defied every assumption about shipbuilding. 2,710 Liberty ships would be launched, more tonnage than the entire German merchant fleet at the start of the war. They would carry 75% of all cargo shipped overseas during World War II. They would prove so durable that hundreds would continue sailing into the 1960s and beyond. The mathematics of industrial annihilation were already being calculated in American shipyards. Every day more Liberty ships slid down the ways. Every week, German U-boats sank fewer ships than American yards built. The strategic equation was simple and terrifying for Germany. America could build ships faster than submarines could sink them. This is the story of how a desperate innovation born from catastrophic losses became an unstoppable force of industrial might. How German naval officers' laughter turned to desperation as they realized they were fighting not just ships, but the entire productive capacity of the American economy. How the ugliest, crudest, most utilitarian cargo ship ever designed became the most important vessel of the Second World War. The Liberty ship was born from disaster. In 1940, as German U-boats ravaged Atlantic convoys, Britain was losing ships 3 times faster than British yards could replace them. Traditional shipbuilding methods required 8 to 12 months to complete a cargo vessel. Skilled riveters, intricate curved hull sections, custom components for each ship. Britain was drowning in a sea of losses with no way to catch up. The British approached American shipyards with an emergency order. 60 cargo ships of a simple British design called Ocean Class. But Henry Kaiser, a dam builder with no shipbuilding experience whatsoever, proposed something radical. Don't build British ships, build American ones, simpler, faster, using mass production techniques from automobile manufacturing. The United States Maritime Commission was skeptical. Kaiser had never built a ship. His proposal violated every principle of traditional naval architecture, all-welded construction instead of riveted, pre-fabricated sections instead of custom fitting, reciprocating steam engines instead of modern diesel or turbines. The design was deliberately archaic, using the simplest possible propulsion system. A 2,500 horsepower triple-expansion steam engine, technology from the 1890s. This choice was strategic. Triple-expansion engines were simple, required no exotic materials, could be manufactured by companies with no marine experience, and were nearly indestructible. But they were slow, inefficient, and generated massive amounts of smoke. Traditional naval architects were horrified. The resulting design, designated EC2-SC1, Emergency Cargo Type 2, steam-powered C1 hull type, was ugly beyond belief. A hull 441 feet long, 57 feet wide, with a deadweight capacity of 10 to 500 tons. 5 cargo holds, 3 forward and 2 aft of the engine room. A superstructure that looked like it was stuck on as an afterthought. No curves anywhere. Flat plates welded together in the simplest possible configuration. The British, desperate for ships, accepted. But they looked at the design and pronounced it a Liberty Fleet ship. a temporary expedient until proper ships could be built. President Franklin Roosevelt, ever the political wordsmith, shortened it to Liberty Ship, and the name stuck. The first Liberty ship, SS Patrick Henry, was launched on September 27, 1941, at the Bethlehem Fairfield Shipyard in Baltimore, 244 days after her keel was laid. By traditional standards, this was remarkable, but Kaiser knew it wasn't good enough. German U-boats were sinking ships daily. America needed to build faster than anyone thought possible. Kaiser revolutionized shipbuilding by treating it like automobile assembly. The hull was divided into prefabricated sections, each weighing up to 70 tons, built separately in assembly areas around the shipyard. Workers could fabricate components on the ground, in comfortable working conditions with proper lighting and tools, no more working in cramped hull sections or dangerous heights. Each section was complete with wiring, piping, even bunks and equipment installed. Then massive cranes lifted these sections into place and welded them together. A ship that traditionally required 12 months could be assembled in weeks. The welding was itself revolutionary. Traditional ships used rivets, millions of them, each installed by hand by skilled workers. A single riveter could install perhaps 200 rivets per day. A Liberty ship would have required over 1 million rivets. Welding eliminated this bottleneck entirely, but welding had a dark secret that would soon terrorize both shipbuilders and sailors. In January 1943, U-boat commanders began receiving puzzling reports from their crews. Allied merchant ships were breaking apart without being torpedoed. On January 16th, the Liberty ship SS John P. Gaines radioed a distress call off the Aleutian Islands. No torpedo, no mine, no attack. The ship's hull had simply cracked in half. The crew watched in horror as the two halves separated and sank in less than 10 minutes. 10 men died in the freezing water. On February 3rd, SS Henry Wynkoop suffered the same fate in the North Atlantic. The hull fractured completely, splitting the ship in two while tied up at a dock in calm weather. Investigators were baffled. On January 4th, SS John Stevenson was loading cargo in harbour when her hull cracked with a sound like a gunshot. The crack propagated completely around the ship's hull in seconds. Only the fact that she was in shallow water prevented her sinking. Over the next 6 months, 12 Liberty ships suffered catastrophic hull failures. 3 broke in half and sank. The remainder suffered cracks so severe they had to be scrapped. German intelligence learned of these failures and issued a gleeful assessment. The American emergency ships are structurally unsound. All welded construction creates a continuous stress path, allowing catastrophic crack propagation. Traditional riveted construction prevents this, as cracks cannot pass through gaps between plates. The Liberty ship program faces imminent collapse due to fundamental design flaws. For several terrifying months, it appeared the Germans were right. American naval architects frantically investigated. What they discovered was a phenomenon called brittle fracture, poorly understood in 1943. Steel, when cold, can transition from ductile behaviour, bending under stress, to brittle behaviour, shattering like glass. The welded construction created continuous stress paths exactly as the Germans had noted. A crack starting at a stress concentration point could propagate through the entire hull structure in seconds. The investigation identified the causes. Poor quality steel in early ships. Some plates had inadequate toughness at low temperatures. Stress concentration points at hatch corners, where the square shape created extreme stress. Poor welding technique by inexperienced workers. Some welds were contaminated or improperly prepared. Most critically, the ship design had sharp corners in the hull structure. Square hatches, right-angle joints, all creating stress risers where cracks could initiate. The solution required modifications to every Liberty ship in production and repairs to those already at sea. Hatch corners were redesigned with rounded transitions to distribute stress. Crack arrestor straps, riveted steel bars, were installed at critical locations to prevent crack propagation. Steel specifications were tightened, requiring better low-temperature toughness. Welders received improved training, and quality control was massively increased. Most elegantly, a few rivets were strategically placed in otherwise welded structures to create crack arrestor points. The cost was enormous, nearly $50 million to modify existing ships and redesign production, but it worked. Hull failures dropped to near zero. The German prediction of program collapse never materialized. Instead, Liberty ship production accelerated. By mid-1943, American shipyards were launching Liberty ships at rates that seemed physically impossible. The Richmond Shipyard No. 2 in California, built on mudflats in just 8 months, became the center of a competition that would shock the world. Henry Kaiser bet his yard supervisors they couldn't launch a Liberty ship in under a month. They accepted the challenge. On November 8, 1942, the keel for SS Robert E. Peary was laid. Prefabricated sections arrived at the building way in a precisely choreographed sequence. Day 1, the keel sections were positioned and welded. Day 2, bottom plates were added. Day 3, lower hull sides went up. By day 4, the basic hull shape was recognizable. The engine, prefabricated as a complete unit, was lowered into place on day 5. Superstructure sections, built separately with all equipment installed, were craned into position on day 6. By day 7, the ship was recognizable, painted with most systems operational. The work continued 24 hours a day under floodlights. Welders, electricians, pipe fitters, riggers, thousands of workers moving in coordinated chaos. On November 12th, 4 days and 15.5 hours after her keel was laid, SS Robert E. Peary was launched. She underwent sea trials and was delivered to the Maritime Commission on November 15th, 7 days after construction began. The achievement made headlines worldwide. German naval intelligence initially reported it as propaganda, impossible to believe. But subsequent Liberty ships continued the trend. The average construction time dropped from 244 days for Patrick Henry to 42 days by late 1943. Some yards achieved 30-day averages. The Richmond yards alone would produce 747 Liberty ships during the war, roughly 1/4 of total production. At peak production in December 1943, American yards launched 3 Liberty ships per day. The German Navy was sinking ships, but for every ship they sank, 3 new ones were hitting the water. Admiral Karl Dönitz, commander of the U-boat force, called it the tonnage war. Germany needed to sink 700,000 tons of Allied shipping per month to strangle Britain. In 1942, U-boats achieved this goal several times, but by 1943, American production had turned the equation upside down. Liberty ships alone were adding 1.5 million tons of new shipping capacity monthly, and that didn't count tankers, victory ships, or other cargo vessels. Dönitz wrote in his diary in August 1943, "The enemy builds ships faster than we sink them. The Battle of the Atlantic is lost not at sea but in American shipyards. We are fighting not England, but American industrial capacity. There is no military solution to this problem. The Liberty ship's design, initially mocked for its simplicity, proved brilliantly suited to mass production. Every Liberty ship was identical, the same engine, the same boilers, the same cargo handling gear, the same electrical systems, the same plumbing. This interchangeability meant spare parts could be stockpiled globally. A pump from one Liberty ship would fit any other Liberty ship. Crews could transfer between vessels with no retraining. Repair facilities needed only one set of specialized tools, but more importantly, the standardization allowed catastrophic production scaling. By 1943, 18 shipyards were building Liberty ships simultaneously. The Kaiser Yards in Richmond, California, the Permanent Metals Yard in Richmond, the Oregon Shipbuilding Corporation in Portland, the California Shipbuilding Corporation in Los Angeles, Todd Bath Iron Shipbuilding in Maine, Bethlehem Fairfield in Baltimore, New England Shipbuilding in Maine, North Carolina Shipbuilding in Wilmington, Delta Shipbuilding in New Orleans, Houston Shipbuilding in Texas, Southeastern Shipbuilding in Georgia, plus 7 more yards, each launching multiple ships monthly. The workforce required was staggering. At peak, over 600,000 workers were employed in Liberty ship construction. The majority had never seen a ship before Pearl Harbor. Housewives, farmers, teenagers, retirees, all trained in weeks to perform specialized tasks. The famous Rosie the Riveter image, actually based on multiple real women, represented the transformation of the American workforce. Women made up over 30% of shipyard workers by 1943. Some shipyards had female welders who could outproduce their male counterparts. The training was intensive but brief. Welding school lasted 2 weeks, pipe fitting 3 weeks, electrical work 4 weeks. Then workers went into the yards under supervision of experienced foremen. The quality control was surprisingly robust given the rushed training. Each ship underwent 6 days of sea trials before delivery. Engines were tested at full power. Cargo handling equipment was operated under load. Watertight integrity was verified. Most remarkably, the ships worked. Despite being built by inexperienced workers using rushed methods, in a fraction of traditional construction time, Liberty ships proved extraordinarily reliable. The U-boats discovered this reliability the hard way. On March 6, 1943, convoy HX-229 departed New York carrying vital war materials to Britain. The convoy included 13 Liberty ships among 40 cargo vessels. German B-Dienst intelligence had broken Allied naval codes and knew the convoy's route. Dönitz positioned 38 U-boats in 3 patrol lines across the expected track. What followed was one of the largest convoy battles of the war. Over 3 days and nights, U-boats made repeated attacks. 21 Allied ships were sunk, including 7 Liberty ships. The Germans proclaimed a great victory, but the reality was more complex. The 7 Liberty ships sunk, absorbed 14 torpedoes between them. One ship, SS James Oglethorpe, took 3 torpedoes and stayed afloat for 5 hours, allowing her entire crew to escape. Another, SS Matthew Maury, took 2 torpedoes, had her bow blown completely off, and still made it to port under her own power, sailing backward for 200 miles. The remaining 6 Liberty ships in the convoy reached Britain without damage. Their cargo, 60,000 tons of ammunition, vehicles, aircraft parts and fuel, sustained British and Soviet forces for weeks. From the German perspective, sinking 21 ships was a tactical victory. From the strategic perspective, America replaced those losses in 7 days. The convoy cycle continued uninterrupted. The Liberty ship's design included features that made it remarkably difficult to sink. The hull was subdivided into watertight compartments. Flooding in one hold didn't necessarily sink the ship. The cargo holds were separated from the engine room by watertight bulkheads. A torpedo hit forward wouldn't disable propulsion. The engine room had watertight doors that could be sealed, creating a survivable citadel. The steam plant was nearly indestructible. Even with extensive damage, if the boilers held pressure, the ship could move. Most importantly, the ships were simply huge. 10,500 tons deadweight capacity meant massive reserve buoyancy. A Liberty ship could lose an entire cargo hold and still float. Several Liberty ships survived catastrophic torpedo damage that would have sunk smaller vessels instantly. SS Stephen Hopkins provided the most remarkable example of Liberty ship toughness in combat. On September 27, 1942, Hopkins was sailing alone in the South Atlantic when she encountered the German surface raider Stier and her escort ship Tannenfels. Both German ships were armed merchant raiders, fast cargo ships converted with concealed heavy guns. They massively outgunned the Liberty ship. Hopkins carried a defensive armament, standard for merchant ships by 1942. 1 4-inch gun on the stern, 2 37mm guns and 6 20mm cannons. Against Stier's 6 5.9-inch guns and Tannenfels' 4 4.1-inch guns, Hopkins was hopelessly outmatched. The German ships closed to 1,000 yards and opened fire. Their first salvos shredded Hopkins' superstructure. The bridge was destroyed, killing the captain and several officers. The engine room took hits, killing crew members and starting fires. The forward holds were pierced, causing flooding. But the gun crews on the stern kept fighting. Ensign Kenneth Willett, the Naval Armed Guard commander, took charge of the 4-inch gun. The crew had never fired it in combat. Under direct fire from German cruisers, they began a duel that should have been suicide. For 20 minutes, Hopkins' lone 4-inch gun exchanged fire. With both German ships, Willett personally aimed each shot while shell fragments and machine gun fire swept the deck. The Liberty ship's gun crew scored at least 35 hits on Stier, including 5 at the waterline that flooded her engine room. Stier's engine room crew abandoned their posts as seawater poured in. Her engines stopped. She was dead in the water and sinking. Tannenfels rescued Stier's crew and both German ships sank. Stier from battle damage and flooding, Tannenfels scuttled by her own crew to prevent capture. Hopkins, ablaze and sinking, continued fighting until her ammunition was exhausted. Her crew abandoned ship. She sank an hour later. Of the 58 crew members, 42 survived. Hopkins remains the only American merchant ship to have sunk a German surface warship in a surface gun action. The 4-inch gun crew, all volunteers, were posthumously awarded the highest decorations. The engagement demonstrated what a Liberty ship could endure. Dozens of hits from heavy guns, the superstructure destroyed, engine room flooded, fires throughout the ship, yet she remained afloat and fighting for over an hour. In the North Atlantic, Liberty ships routinely survived damage that would have doomed traditional cargo vessels. The all-welded construction, initially criticised, proved advantageous. Riveted ships could suffer catastrophic rivet failure, entire plates tearing away. Welded ships maintained structural integrity even when heavily damaged. The armour protection was minimal by warship standards, but substantial for merchants. The engine room had limited armour around vital machinery. The bridge had splinter protection. The ammunition magazines were protected by cofferdams, empty spaces filled with water to absorb explosions. This protection was enough to keep the ship operational through attacks that would disable unprotected merchants. By mid-1944, the United States had achieved something unprecedented in maritime history. There were more Liberty ships afloat than the entire British merchant fleet at the start of the war. Over 2,000 Liberty ships were in service, carrying everything needed to sustain Allied forces on 4 continents. The cargo carried was staggering in its scope and volume. Tanks, aircraft, trucks, locomotives, railway cars, ammunition, food, fuel, medical supplies, construction equipment, spare parts, raw materials, everything needed to fight a global war. A single Liberty ship could carry 2,140 jeeps, or 440 light tanks, or 230 million rounds of rifle ammunition, or enough food to feed an army division for a month. The 2010 Liberty ships built carried a combined 75 million tons of cargo during the war. To put this in perspective, the entire German merchant fleet in 1939 totaled 4.5 million tons. Liberty ships alone carried cargo equivalent to Germany's entire pre-war merchant capacity 16 times over. The global reach was extraordinary. Liberty ships sailed to every theatre of war. They supplied British forces in North Africa. They carried material to the Soviet Union through Murmansk and Vladivostok. They supported MacArthur's island hopping campaign in the Pacific. They delivered fuel to airfields in China. They carried troops to Italy, France, and the Philippines. The Arctic convoys to Murmansk proved the most dangerous route. German forces in Norway attacked with U-boats, aircraft, and surface ships. The weather was treacherous, with massive storms, ice, and temperatures that could kill an exposed man in minutes. Liberty ships on the Murmansk run faced the highest casualty rates of any convoy route. Over 350 merchant ships sailed to Russia. 104 were sunk. Of these, 29 were Liberty ships. But the 321 Liberty ships that completed the journey delivered 1.5 million tons of supplies to Soviet forces. Tanks, aircraft, trucks, ammunition, food. Material that helped the Red Army survive, rebuild, and eventually destroy the Wehrmacht on the Eastern Front. Stalin, not known for praising capitalist achievements, acknowledged the importance. The Liberty ships, he told Roosevelt at Tehran, have delivered more to our victory than all our own efforts combined. Without American supplies, the Soviet people would still be fighting, but much farther east. The D-Day invasion demonstrated American logistical supremacy, built on Liberty ship capacity. In the 3 months following June 6, 1944, over 2 million men, 500,000 vehicles, and 3 million tons of supplies crossed the English Channel. Liberty ships, sailing directly into Normandy beaches after the initial assault, delivered the bulk of this material. The ships would anchor offshore, lower their cargo booms, and offload directly to smaller vessels or temporary piers. Some Liberty ships were deliberately beached, unloaded, then pulled off by tugs at high tide. Others were sunk to create breakwaters for artificial harbours. The Mulberry harbours used 76 obsolete cargo ships and warships as breakwaters. Several were Liberty ships deemed too damaged for continued service. Even in death they served the invasion. The sustained tonnage delivery made Germany's strategic situation hopeless. By late 1944, Allied forces in Europe were consuming 25,000 tons of supplies daily. Ammunition alone required 10,000 tons per day during major offensives. This material arrived on Liberty ships. The German High Command understood the implications. General Alfred Jodl, Chief of Operations, stated in a December 1944 meeting with Hitler, "The enemy's logistics are inexhaustible. They have ships without number. When we destroy their ports, they build new ones. When we sink their ships, more arrive. Their material superiority is not tactical, it is absolute. We are fighting the entire American economy." The Luftwaffe attempted to disrupt this flow. German aircraft attacked convoys, ports, and anchorages. But by 1944, Allied air superiority was complete. German pilots who reached the convoys found them protected by fighters, anti-aircraft guns, and barrage balloons. The cost of attacking ships became prohibitive. Oberleutnant Franz Heiler, a Luftwaffe bomber pilot who survived the war, later recalled attacking a convoy off Normandy in July 1944. "We came in low, 6 aircraft in formation. The flak was unbelievable. Every ship was firing. The sky was filled with explosions and tracers. We dropped our bombs from 500 meters and turned away. I saw one bomb hit a cargo ship, a large one, American, built with the flat sides. The explosion was substantial. Surely the ship would sink. I watched as we escaped. The ship was still there, still moving, smoke pouring from a hole in the deck but otherwise unaffected. We lost 2 aircraft. I never volunteered for anti-shipping missions again. The Liberty ship's ultimate vindication came in the final months of the war. As Allied forces advanced into Germany, the logistical tail stretched over 500 miles from ports to the front lines. Trucks, trains, and pipelines moved supplies, but Liberty ships delivered those supplies to European ports in quantities that made the final offensives possible. The Rhine crossing in March 1945 required 60,000 tons of bridging equipment, ammunition, and fuel prepositioned before the assault. Liberty ships delivered this material through Antwerp, which handled 40,000 tons daily at peak. The capture of Antwerp as a functioning port was considered as important as winning major battles. One functioning port meant hundreds of Liberty ships could unload simultaneously. In the Pacific, Liberty ships solved the tyranny of distance. Island bases thousands of miles from supply sources required constant replenishment. Fuel, ammunition, food, construction materials, replacement equipment. Everything arrived on cargo ships. The scale was astronomical. The invasion of Okinawa in April 1945 involved 1,300 ships. Over 500 were cargo vessels, mostly Liberty ships. They delivered 200,000 troops and 750,000 tons of supplies. This sustained the bloodiest battle of the Pacific War for 3 months. Admiral Chester Nimitz, Commander-in-Chief Pacific Fleet, stated bluntly, "Without the Liberty ships, the Pacific campaign would have been impossible. We could not have sustained forces across such distances without an unlimited supply of cargo capacity. The Liberty ships gave us that capacity. By war's end, Liberty ship production had created a surplus of cargo capacity. The last Liberty ship, SS Albert M. Bow, was launched on October 26, 1945. By then, 2,710 Liberty ships had been completed. 200 remained under construction when contracts were cancelled. Of the 2,710 built, 200 had been sunk by enemy action. 31 were lost to marine accidents. 24 were damaged beyond repair. This left 2,455 operational Liberty ships at war's end, more cargo capacity than the entire world's merchant fleet in 1939. The disposal of this surplus presented an unprecedented problem. What do you do with 2,400 surplus cargo ships? The initial solution was preservation. 2,277 Liberty ships were placed in reserve fleets, anchored in sheltered waters, maintained in preservation status for potential future use. The National Defense Reserve Fleet, created in 1946, stored these ships in groups. The James River Reserve Fleet in Virginia held over 800 ships at peak. Suisun Bay in California held 400. The Beaumont Reserve Fleet in Texas held 300, plus smaller fleets in Oregon, Washington, and Florida. From the air, these reserve fleets looked surreal. Hundreds of identical ships anchored in neat rows stretching for miles. Ghost fleets maintained by skeleton crews who preserved machinery, sealed openings, and prevented deterioration. The expectation was that most would never sail again. They were emergency capacity, insurance against future conflicts. The prediction was wrong. The ships proved their worth repeatedly over the next decades. During the Korean War, 540 Liberty ships were reactivated and returned to service. They carried supplies to sustain United Nations forces in Korea, demonstrating that even 10-year-old emergency cargo ships could still perform. During the Suez Crisis in 1956, Liberty ships provided emergency cargo capacity when the canal was blocked. During the Vietnam War, 82 Liberty ships came out of reserve to carry supplies across the Pacific. As late as 1968, Liberty ships were still sailing in commercial service. The design, so crude and temporary in concept, proved remarkably durable. Several Liberty ships sailed for over 30 years. SS John W. Brown and SS Jeremiah O'Brien remain operational today as museum ships, fully functional and capable of sailing. O'Brien crossed the Atlantic in 1994 for the D-Day 50th anniversary. At 53 years old, she completed the voyage without significant mechanical issues, demonstrating the fundamental soundness of her engineering. The impact on post-war shipping was profound. The Liberty ship's mass production techniques revolutionized shipbuilding globally. Welded construction became standard. Prefabrication became normal. The idea that ships could be mass-produced like automobiles became accepted. Japan and Korea, rebuilding their shipbuilding industries after the war, adopted American mass production methods. By the 1960s, Japanese yards were the world's most productive, building supertankers and container ships using techniques pioneered in American Liberty shipyards. The standardization principle also influenced post-war shipping. Container ships, developed in the 1950s, used standardized containers that could be handled by standardized equipment. This interoperability, pioneered by Liberty ships with their identical fittings and equipment, became fundamental to modern global trade. The economic impact defied calculation. The 2010 Liberty ships cost approximately $2 billion to build, roughly $740,000 per ship. They carried cargo worth over $50 billion during the war. The return on investment was 25-1 before considering strategic value. By comparison, Germany spent over $3 billion on U-boat construction and operations. They built 162 U-boats during the war. These submarines sank approximately 3,000 Allied merchant ships, totaling 14 million tons. But Allied production, primarily Liberty ships, added over 40 million tons of new shipping during the same period. The Germans sank 3,000 ships. America built 5,000. The tonnage war that Admiral Dönitz thought he could win was lost before it began. German intelligence had calculated that sinking 700,000 tons monthly would strangle Britain. They never calculated that America could build 1.5 million tons monthly. The strategic failure was absolute. Perhaps the most telling assessment came from Grand Admiral Karl Dönitz himself. At his war crimes trial in Nuremberg in 1946, prosecutors questioned him about the U-boat campaign. Dönitz was asked, "At what point did you realize the Battle of the Atlantic was lost?" His answer was remarkably candid. In August 1942, I received intelligence reports about American cargo ship production. The numbers seemed impossible, 3 ships per day. I thought it was propaganda. I ordered verification. The reports were confirmed. At that moment, I knew the tonnage war was unwinnable. We could sink every ship in every convoy and still lose. The Americans were not building ships. They were manufacturing them like artillery shells. Individual losses were irrelevant. The production capacity was unlimited. We were fighting not a navy but a factory system that could outproduce the entire German war economy, while simultaneously building bombers, tanks, and everything else. The realization came too late. By August 1942, over 400 Liberty ships were already afloat. Another 1/500 were under construction. The strategic die was cast. The technical achievement of the Liberty ship program remains staggering even 80 years later. 2,110 ocean-going cargo ships built in under 4 years. Construction time reduced from 244 days to an average of 42 days. A workforce of 600,000, mostly unskilled, trained and producing ships to exacting standards. Prefabrication and modular construction techniques that predated modern manufacturing by decades. Quality control systems that ensured 99% of ships delivered were fully operational. A logistical coordination system that supplied 18 shipyards with millions of tons of steel, machinery and components without disrupting production. The statistics are almost incomprehensible. 15 million man-hours per ship, 250,000 separate parts, 3 million rivets and bolts, 7 million pounds of steel, 20 miles of piping, 5 miles of electrical cable, every ship identical, every part interchangeable. The human cost was also significant. Over 5,000 workers were killed in shipyard accidents during the war. The rushed production schedules, inexperienced workforce, and dangerous conditions created inevitable tragedies. Falling from heights, crushed by cranes, burned by welding accidents, electrocuted or drowned during launches. Each Liberty ship represented not just industrial achievement, but human sacrifice. The environmental legacy was complex. The ships themselves were remarkably clean for their era. Coal-fired boilers were standard, producing smoke but no oil pollution. The steel construction was entirely recyclable. Hundreds of Liberty ships were eventually scrapped, their steel recycled into new vessels, but others were simply abandoned. Several Liberty ships were sunk as artificial reefs, creating underwater habitats. Others were used as breakwaters. A few were deliberately sunk in deep water as disposal methods. The Ghost Fleet of Mallows Bay in Maryland contains dozens of World War I-era ships, plus a few Liberty ships, slowly deteriorating into the riverbed. The strategic lessons of the Liberty ship program influenced Cold War planning. The United States maintained reserve fleets specifically as surge capacity for future conflicts. The Ready Reserve Force, established in the 1970s, kept cargo ships in 5-day activation status, able to support military deployments rapidly. This concept traced directly to Liberty ship mass mobilization. The Soviet Union, having received over 400 Liberty ships through Lend-Lease, studied American mass production methods intensively. Post-war Soviet cargo ships used welded construction and standardized designs clearly influenced by Liberty ship engineering. Even enemies learned from American industrial methods. In 1985, the Liberty Ship Memorial Project interviewed surviving German naval officers about their wartime experiences. Fregattenkapitan Peter Kremer, who commanded U-333 and survived the war, provided a remarkable perspective. "We knew we were losing by 1943. Every patrol, more Allied ships, every convoy, stronger escorts, every return to base, fewer U-boats came home, but we kept fighting because we were told the enemy was weakening. We were not told the truth, that America was building ships as fast as we could build torpedoes. I once attacked a convoy and sank 2 cargo ships, identical vessels, flat-sided American types. I thought it was a significant victory. Later, I learned these ships had been built in less time than my patrol lasted. What kind of war could we win against an economy that could replace losses before we returned to port?" The American Liberty ships were the most important weapon of the war. Not the most powerful, not the most sophisticated, but the most important. They rendered our entire strategy obsolete. We fought to sink tonnage faster than it could be replaced. The Americans made replacement irrelevant through unlimited production. It was not a war. It was an industrial demonstration. The final vindication of the Liberty ship came not from military historians, but from the merchant sailors who sailed them. The SS Jeremiah O'Brien, maintained as a museum ship in San Francisco, hosts reunions of merchant mariners who served on Liberty ships during the war. These men, now in their 90s or deceased, spoke of the ships with genuine affection. Captain Fred Clark, who commanded 3 different Liberty ships during the war, spoke at a 1994 reunion. "We called them ugly ducklings. They were slow. They rolled like pigs in heavy seas. The accommodations were Spartan, but they were honest ships. They did what they were built to do without complaint. I was torpedoed twice. Both times the ship stayed afloat long enough for the crew to escape. I watched a Liberty ship take a kamikaze hit in the Pacific and still make port. These were not beautiful ships, but they were survivors, and they brought us home." The Liberty ship program built more than vessels. It built a maritime industrial base that sustained America's superpower status for decades. It trained hundreds of thousands of workers in manufacturing techniques that revolutionized post-war industry. It demonstrated that American industrial capacity could solve strategic problems that military force could not. In museums across America, preserved Liberty ships stand as monuments to industrial achievement. The SS Jeremiah O'Brien in San Francisco, the SS John W. Brown in Baltimore. Both are fully operational, maintained by volunteer crews of aging veterans and maritime enthusiasts. They sail occasionally, demonstrating that 80-year-old emergency cargo ships built in 6 weeks can still cross oceans reliably. The irony is profound. Ships built as temporary expedients designed to last 5 years have survived 8 decades. Ships mocked as floating coffins proved nearly unsinkable. Ships dismissed as crude barges became the most successful cargo design in history. German admirals laughed at the Liberty ships in 1942, seeing only their ungainly appearance and crude construction. They stopped laughing by 1943 when convoys of identical vessels kept arriving despite catastrophic U-boat attacks. By 1944, German Naval Command wasn't laughing at all. They were drowning in American steel. The final statistics tell the story with brutal clarity. German U-boats sank 196 Liberty ships during the entire war, roughly 7% of total production. This represented Germany's maximum effort, expending thousands of torpedoes, losing hundreds of submarines and their irreplaceable crews. In exchange, they temporarily removed vessels that were replaced within weeks. The exchange rate was catastrophically unfavourable. Each U-boat cost approximately $2.5 million to build and required 9 months construction time. Each Liberty ship cost $740,000 and took 42 days. Germany lost 783 U-boats during the war, roughly 30,000 submariners killed. The U-boat arm suffered 75% casualties, the highest of any military service in any nation during World War II. These losses achieved tactical successes. Individual ships sunk, convoys disrupted, but strategic failure was absolute. The Battle of the Atlantic, often portrayed as a near-run thing in popular histories, was actually decided by industrial mathematics that made German victory impossible. Admiral Dönitz needed to sink more tonnage than the Allies could build. At no point after mid-1943 did Germany achieve this goal. At peak effectiveness in November 1942, U-boats sank 729,000 tons of Allied shipping. That same month, Allied shipyards launched 1.2 million tons of new ships. The gap only widened from there. By 1944, Liberty ship production had created such surplus capacity that the Maritime Commission began cancelling orders, not because production was too slow, but because it was too fast. There were literally more ships than cargoes to fill them. This represented a strategic transformation unprecedented in military history. A nation had built itself from desperate shortage to overwhelming surplus in less than 3 years. The human stories behind the statistics reveal the Liberty ship's impact on ordinary lives. Over 250,000 merchant mariners served on Liberty ships during the war. They faced casualty rates higher than any military service except submarine crews. 1 in 26 American merchant sailors died during the war, a casualty rate of 3.9%. For comparison, the US Army suffered 2.5% casualties, the Navy 1.6%. Merchant mariners faced the same dangers as combat forces: torpedoes, bombs, shells, mines, weather, without military training or support. Yet they kept sailing. Liberty ships departed American ports loaded with ammunition, fuel, and explosives. They crossed oceans knowing that a single torpedo could vaporize the entire ship in seconds. They sailed through hurricane-force storms in the North Atlantic, where waves could break a ship in half. They anchored off invasion beaches under shell fire. They maintained schedules that would have been considered impossible in peacetime. The Liberty ship crew was typically 44 men. The captain, 3 deck officers, 3 engineering officers, a radio operator, a purser, and 36 unlicensed crew. Plus a naval armed guard detachment of 15 to 30 sailors to man the defensive guns. These men, most in their late teens or early 20s, lived in Spartan conditions. The accommodations were functional but minimal. Small cabins, shared facilities, constant noise from the engine room, vibration throughout the ship. In the North Atlantic, the ships rolled viciously in heavy seas, making even simple tasks like eating or sleeping difficult. The food was notoriously poor on early Liberty ships. Fresh provisions ran out within days of departure. The remainder of the voyage meant canned goods, dried foods, and whatever the cook could create from limited supplies. Complaints about Liberty ship food became legendary in the merchant marine. One common joke was that the only thing worse than Liberty ship food was not having a Liberty ship to serve it on. Despite hardships, the crews developed fierce pride in their vessels. Each ship had a personality, quirks in handling or machinery that became familiar. experienced crews could identify their ship by the sound of the engine alone. The rhythm of the triple expansion engine, the particular vibration pattern, became as familiar as a heartbeat. The naming of Liberty ships reflected American history and values. Ships were named after famous Americans, signers of the Declaration of Independence, prominent citizens, labor leaders, scientists, and educators. SS Booker T. Washington, launched in 1942, was the first American cargo ship named for an African American. SS Harriet Tubman followed. These naming choices made political statements about American ideals even while segregation remained legal. Some names proved prophetic. SS Robert E. Peary, the ship built in record time, was named for the Arctic explorer. She sailed to Russia through Arctic waters, carrying supplies that helped Soviet forces survive German invasion. SS Patrick Henry, the first Liberty ship, was named for the revolutionary who declared, "Give me liberty or give me death." She survived the war and continued sailing commercially until 1958, embodying the endurance her namesake represented. Other names became famous through their ship's actions. SS Stephen Hopkins, which sank a German raider, carried the name of a declaration signer from Rhode Island. Her crew's heroism validated the name. SS Jeremiah O'Brien, now a museum ship, honoured a Revolutionary War naval hero. Her survival and preservation allowed that hero's story to be told to new generations. The Liberty ships that survived the war faced an uncertain future. Many were sold to foreign nations as war reparations or aid. Greece received over 100 Liberty ships, which formed the core of the rebuilt Greek merchant fleet. These ships, renamed and modified, sailed under the Greek flag into the 1970s. Italy received 85 Liberty ships. China received 35. The Soviet Union kept the 400 received during Lend-Lease, refusing to return them as agreed. These ships, redesignated by the Soviets, served in the Soviet merchant fleet until the 1960s. Private shipping companies purchased hundreds more at surplus prices. A Liberty ship that cost the government $740,000 to build sold for as little as $50,000 in 1946. Maritime companies acquired entire fleets at bargain prices. Some companies were founded entirely on surplus Liberty ships, building global shipping operations from these emergency vessels. The conversion of Liberty ships to specialized purposes demonstrated their versatility. Some became tankers, their cargo holds converted to fuel tanks. Others became refrigerated ships for meat and produce transport. Several were converted to passenger ships carrying immigrants to America. SS Marine Jumper was converted to a livestock carrier, transporting horses and cattle. SS Charles L. McNary became a research vessel for oceanographic studies. The most unusual conversions involved military applications. Several Liberty ships were converted to helicopter carriers for anti-submarine warfare. Others became radar picket ships floating early warning stations. Some were fitted, with launch rails for V-2 rocket research. One Liberty ship, SS Albert W. Stevens, was converted to track early space launches, serving in this role into the 1960s. The atomic age brought new purpose for some Liberty ships. The Bikini Atoll nuclear tests in 1946 used surplus vessels as targets. Several Liberty ships were positioned at various distances from ground zero to measure blast effects. These ships, obsolete for commerce but valuable for science, provided crucial data about nuclear weapon effects on ships. Most were vaporized or sunk. One survivor, severely damaged by radiation, was eventually scuttled. Even in death, Liberty ships served national needs. The Cold War reserve fleets represented the ultimate vindication of the Liberty ship concept. Over 2,000 ships preserved in mothballs, ready for reactivation in emergency. The cost of maintaining these reserve fleets was substantial, tens of millions annually, but far less than building equivalent capacity from scratch. The strategic calculation was simple. Keep the ships preserved for potential future conflict, when surge sealift capacity would be essential. This calculation proved correct repeatedly. Korean War activation demonstrated the reserve concept worked. Ships preserved for 5 years returned to service within weeks. The Cuban Missile Crisis in 1962 saw emergency preparations to reactivate Liberty ships if conflict erupted. The Vietnam War proved the ships could be reactivated even after 20 years in reserve. But time eventually defeated even these durable vessels. By the 1970s, most surviving Liberty ships were 30 years old. Steel corrodes, machinery wears out, technology advances. The surviving reserve fleet ships were systematically scrapped. The steel was recycled, the machinery salvaged, the ships reduced to scrap metal. By 1990, fewer than 100 Liberty ships remained in any form. Most were hulks, no longer seaworthy, awaiting final scrapping. The environmental concerns about the reserve fleets grew in the 1990s. Deteriorating ships leaked oil and hazardous materials. Local communities near reserve anchorages demanded removal of the ghost fleets. The Maritime Administration began systematic scrapping programs. By 2000, most reserve fleet anchorages were empty. The massive fleets that had stretched for miles were gone, reduced to memories and photographs. The two museum ships, Jeremiah O'Brien and John W. Brown, survived through dedicated preservation efforts. Volunteer crews, many of them World War II veterans, maintained these ships in operating condition. The costs were substantial, requiring constant fundraising. But the commitment to preserving at least two examples of Liberty ships for future generations drove the efforts. The 50th anniversary of D-Day in 1994 provided dramatic proof that the preservation was worthwhile. SS Jeremiah O'Brien, 53 years after her launch, sailed from San Francisco to England and Normandy. The voyage took 38 days, including stops in ports, along the way. The old ship, maintained by her volunteer crew, completed the Atlantic crossing without significant mechanical problems. Her arrival in Normandy for the anniversary commemoration was emotional. One of the last surviving vessels from the actual invasion still capable of sailing. The technical achievement of keeping a 50-year-old emergency-built cargo ship operational impressed maritime engineers worldwide. The design's fundamental soundness, the quality of materials despite rushed construction, and the dedication of the maintenance crew all contributed. But perhaps most impressive was the realization that Liberty ships, built for 5-year lifespans, could last indefinitely with proper care. Modern maritime experts studying Liberty ships have revised earlier dismissive assessments. What appeared crude in 1942 now appears elegantly simple. The decision to use reciprocating steam engines instead of more advanced turbines or diesels, initially criticized, proved brilliant. The simple engines could be manufactured in quantity, maintained by crews with limited training, and repaired with basic tools. Complexity is the enemy of the mass production and field reliability. Liberty ships avoided complexity ruthlessly. The all-welded construction, source of the early fracture problems, proved superior to riveted construction once the technical issues were resolved. Modern ships are all welded. The Liberty ship program provided the engineering experience that made this transition possible. The lessons learned from Liberty ship fractures led directly to improved steel specifications and welding techniques used in all subsequent ship construction. The modular prefabrication techniques pioneered in Liberty ship construction revolutionized shipbuilding globally. Modern shipyards build sections separately and assemble them, exactly as Kaiser's yards did in 1942. Container ships, cruise liners, and naval vessels all use prefabrication methods developed for Liberty ship mass production. The technique considered radical in 1942 became standard practice by 1970. The logistics coordination required for Liberty ship production influenced modern supply chain management. Delivering millions of tons of components to 18 shipyards simultaneously required unprecedented coordination. The systems developed for this purpose, using early data processing equipment and sophisticated scheduling, predated modern computerized logistics by decades. Business schools study Liberty ship production logistics as an early example of successful large-scale supply chain management. The economic multiplier effect of Liberty ship construction reshaped American industry. Steel mills expanded capacity to provide ship plate. Engine manufacturers tooled up for marine engines. Electronics companies produced navigation and communication equipment. Thousands of suppliers provided everything from rivets to life preservers. This industrial mobilization created capabilities that persisted after the war, supporting America's post-war economic dominance. The social impact was equally profound. The shipyards employed hundreds of thousands of workers who had never worked in industry before. Women, African Americans, and other groups previously excluded from industrial employment found opportunities. The wages were good, union membership was strong, and the work, while dangerous, provided steady employment. Many workers remained in maritime industries after the war, forming the core of America's post-war industrial workforce. The training programs developed for Liberty ship construction influenced vocational education for decades. Teaching complex skills to inexperienced workers in weeks required innovative instructional methods. The programs developed for shipyard training, emphasizing hands-on experience and competency-based assessment, became models for technical education nationwide. The racial integration of shipyard workforces, while imperfect and often contentious, represented significant progress from pre-war segregation. African American workers comprised over 10% of the shipyard workforce by 1943. They held positions from laborers to skilled welders and supervisors. While discrimination remained prevalent, the shipyards provided employment opportunities that previously didn't exist. Several prominent civil rights activists cited shipyard employment as crucial to their development. The women who worked in shipyards, memorialized as Rosie the Riveter, proved that gender was irrelevant to industrial capability. Female welders, electricians, and machinists performed as well or better than male counterparts. The percentage of women in some shipyards exceeded 30%. Their work directly contradicted pre-war assumptions about women's industrial capabilities. While many women were forced from industrial jobs after the war, the precedent was established. Future generations of women entering industrial careers built on foundations laid in wartime shipyards. The international legacy of Liberty ships extended beyond the vessels themselves. Nations that received Liberty ships as aid or reparations used them to rebuild their merchant fleets. The engineering knowledge transferred with the ships helped reconstruct war-shattered maritime industries. Greek shipowners, operating surplus Liberty ships, built shipping empires that persist today. Several major international shipping companies trace their origins to surplus American cargo vessels acquired in the late 1940s. The Soviet experience with Liberty ships was particularly significant. The USSR received over 400 Liberty ships through Lend-Lease, more than any other nation. These ships, superior to most Soviet-built cargo vessels, provided models for Soviet maritime development. Post-war, Soviet merchant ships borrowed heavily from Liberty ship design features. The cold relationship between America and the Soviet Union meant this technological transfer was never acknowledged officially, but Soviet maritime engineers privately admitted the Liberty ship's influence on their designs. The environmental benefits of Liberty ship steel recycling were substantial. Each scrapped Liberty ship provided roughly 7 million pounds of steel, all recyclable. This steel, already processed and refined, required far less energy to reuse than producing new steel from ore. The thousands of Liberty ships scrapped in the 1950s through 1980s provided millions of tons of recycled steel for new construction. Several buildings, bridges and ships built in the 1960s contained steel originally forged for Liberty ships in the 1940s. The artificial reef programs using deliberately sunk Liberty ships created unexpected ecological benefits. Several Liberty ships were cleaned of hazardous materials and sunk in designated locations to create artificial reefs. These steel structures, massive and complex, provided habitat for fish, coral, and other marine life. Marine biologists studying these artificial reefs found they developed diverse ecosystems within years. The Liberty ships, built to carry cargo across oceans, found final purpose as underwater habitats supporting marine biodiversity. The cultural impact of Liberty ships extended into literature, film, and art. Dozens of novels featured Liberty ship crews and their wartime experiences. Films used Liberty ships as settings for maritime drama. Artists painted Liberty ships in convoy, Liberty ships under attack, Liberty ships arriving in port with vital cargo. The distinctive silhouette, so ungainly yet so purposeful, became iconic of American industrial might. The most famous Liberty ship in popular culture never actually existed. The film Action in the North Atlantic from 1943 starred Humphrey Bogart as a merchant marine officer on a Liberty ship running the Murmansk route. The film, shot using actual Liberty ships and featuring realistic combat scenes, brought merchant marine service to public attention. It emphasized the danger, the courage, and the critical importance of merchant shipping to the war effort. The film's portrayal of Liberty ships as tough, reliable vessels helped counter earlier negative perceptions. John Steinbeck's wartime journalism included accounts of Liberty ship convoys. His descriptions of merchant sailors, ordinary men doing extraordinary work, helped Americans understand the human side of maritime logistics. Steinbeck recognized that Liberty ships, represented something profound about American character: practical, unpretentious, focused on function over form, but ultimately effective and enduring. The reunion associations formed by Liberty ship veterans kept the memory alive for decades. Annual gatherings brought together men who had sailed on the same ships, faced the same dangers, shared the same experiences. These reunions, held well into the 21st century, allowed aging veterans to reconnect and ensure their stories weren't forgotten. The youngest Liberty ship veterans are now in their late 90s. Soon, no one alive will have actual experience sailing these vessels. The historical scholarship on Liberty ships has expanded significantly in recent decades. Early accounts focused on the dramatic aspects, the speed of construction, the combat experiences, the torpedoes and kamikaze attacks. More recent scholarship examines the industrial organization, the labor relations, the technological innovations, and the long-term impact on maritime industry. Academic conferences have analyzed Liberty ship construction as a case study in large-scale manufacturing, logistics coordination, and quality control under pressure. The comparison with other wartime production programs highlights Liberty ship achievements. The United States produced 300,000 aircraft during World War II, an astounding total. But each aircraft, while complex, was far smaller and simpler than a ship. Liberty ships represented construction on a scale that dwarfed even aircraft production. A single Liberty ship contained more steel than 50 heavy bombers. The engineering complexity, while deliberately simplified, still exceeded that of most aircraft. Building 2,710 ocean-going ships in 4 years represented an achievement equal to the more publicized aircraft production. The tank production comparison is equally instructive. America built approximately 89,000 tanks during the war, including all types from light tanks to heavy models. Each tank, while mechanically complex, weighed about 30 tons and required far less material than a 10,500-ton cargo ship. Yet tank production receives far more historical attention than Liberty ships. The reason is partly timing. Tanks were produced throughout the war. Liberty ship production peaked in 1943 and declined as capacity exceeded need. But the strategic impact of Liberty ships arguably exceeded that of tanks. Tanks won battles. Liberty ships won the war by making sustained operations possible. The comparison with German production reveals the fundamental disparity that made German defeat inevitable. Germany produced approximately 67,000 aircraft during the entire war, less than 1/4 of American production. German tank production totaled 49,000 vehicles, roughly half the American total. But German cargo ship production during the war was negligible, perhaps 200 vessels total. Germany never developed Liberty ship equivalents, never implemented mass production of merchant vessels, never created the maritime capacity necessary to sustain a global war. The strategic blindness this represented was remarkable. German planners understood that Britain depended on maritime logistics. The entire U-boat campaign was premised on sinking ships faster than they could be replaced. Yet Germany never asked the crucial question: what if the enemy can build ships as fast as we build submarines? The failure to anticipate American industrial capacity meant the U-boat campaign was strategically futile from the start. Admiral Dönitz's post-war writings revealed his belated understanding. He wrote extensively about U-boat tactics, technology, and operations. But on the subject of American shipbuilding, his tone became almost bewildered. He simply couldn't comprehend how a nation could build ships so fast, so cheaply, in such numbers. His calculations, based on traditional shipbuilding assumptions, were obsolete before the war began. The Americans hadn't played by the rules Dönitz understood. They had changed the rules entirely. The Liberty ship program demonstrated that industrial capacity was itself a weapon system. The ships weren't particularly fast or heavily armed. Their defensive armament, typically 1 4-inch gun, 2 37mm guns, and 6 20mm cannons, was minimal. They couldn't fight effectively against warships, couldn't outrun submarines, couldn't survive determined air attack. Individually, each Liberty ship was vulnerable, but collectively they were invincible. No enemy could sink them as fast as American yards built them. This collective invulnerability through mass production represented a new form of naval power. The strategic implications extended beyond World War II. The Cold War concept of mutually assured destruction rested partly on America's ability to sustain global military operations indefinitely. This capability traced directly to experience gained from Liberty ship logistics. The certainty that America could maintain supply lines to forward bases, could sustain allies with material shipments, could project power globally through maritime logistics, influenced Soviet strategic calculations. The Liberty ship legacy lived in the confidence that American industrial capacity could support whatever military operations were required. The technical specifications of Liberty ships seem modest by modern standards. A top speed of 11 knots, approximately 12.5 miles per hour, was slow even in 1943. Modern container ships cruise at 25 knots. The cargo capacity of 2,500 tons is dwarfed by modern ships, carrying 200,000 tons or more. The crude steam propulsion has been completely replaced by diesel engines. Yet Liberty ships accomplished their mission perfectly. They moved cargo reliably, survived enemy action at acceptable rates, required minimal crew training, and cost relatively little to build and operate. By these functional measures, they may have been the most successful ship design in history. The legacy question remains, how should history remember the Liberty ships? They weren't beautiful. They weren't particularly innovative in individual components. They didn't represent cutting-edge technology. What they represented was the power of pragmatic engineering backed by industrial capacity. The recognition that winning a global war required logistics more than tactics, production more than innovation, quantity as its own form of quality. German admirals laughed at Liberty ships in 1942 because the ships offended traditional naval aesthetics. They were ugly, crude, mass-produced. Everything a proper ship shouldn't be. What the Germans failed to understand was that aesthetics were irrelevant to function. The Liberty ships didn't need to be beautiful. They needed to carry cargo across oceans, survive enemy action when possible, be replaced quickly when sunk, and above all, be produced in quantities that made German interdiction futile. They accomplished all of these goals perfectly. By 1945, no German admiral was laughing. They were trying to explain to their superiors how Germany had lost the Battle of the Atlantic despite tactical successes. The explanation was uncomfortable. Germany had fought brilliantly and lost absolutely because they were fighting American factories, not American ships. Individual Liberty ships could be sunk. American productive capacity could not. The final measure of Liberty ship success came decades after the war. When maritime historians compiled lists of the most important ships in history, Liberty ships ranked alongside revolutionary designs like HMS Dreadnought and USS Monitor. Not because they were revolutionary in design, but because they were revolutionary in concept. They proved that ships could be mass-produced, that quantity had its own strategic value, that industrial capacity properly directed could win wars before the first shot was fired. Today, 2 Liberty ships remain operational, preserved as floating museums. Thousands of people tour them annually, walk their decks, climb down to their engine rooms, see the cramped crew quarters and the massive cargo holds. These visitors, most born long after World War II ended, try to understand how these crude vessels changed history. The explanation is simple but profound. Liberty ships won the war not by fighting, but by existing. Their presence in overwhelming numbers made German victory impossible and Allied victory inevitable. Sometimes the most powerful weapon isn't the most sophisticated. Sometimes it's simply the most numerous.